All right, so let's do a section of the proof by contrapositive. So this is also a very useful technique, especially when you have the case of proof, um, when you have the case of the proposition where you have the if-then structure. Okay, so maybe when you look at a problem and the proposition is if-then statement, then you can, think about proving by contrapositive. So, how do I use this thing called contrapositive? So let's see another example here. Let's say we have a proposition that if if it rains, then baseball is canceled. Let's say we have such statement. Now, would the negative of this proposition still be true? Like if in here I'm just saying the negative as in if it doesn't rain, then baseball is not canceled. Is this always true? Well, actually, no, right? If it rains, then baseball is canceled. It doesn't directly mean that if it doesn't rain, the baseball is not canceled. Well, there could be other causes to the baseball game that even if it doesn't rain, then the baseball is canceled for other reason. Maybe there's another, atmospheric disaster that we are dealing with. So that's not the negative version of this statement. Instead, what we do is we need to change the other way. So we're going to find the non version of this, and then we're also going to change the A and B clauses. So instead of saying if it doesn't rain, then the baseball is not canceled, we're going to say that if baseball is not canceled, then it doesn't rain. Does this make sense? If the baseball is not canceled, then it doesn't rain. Well, if you put your heads around it, then yes, this statement is definitely true for sure. Because if baseball is not canceled, like if the game is on, then it must be not raining, right? Because baseball cannot be played if it's raining. So if I write this in a more general format, we can say that if A, then B statement, this can be switched with if not B, then not A. Okay. So we're switching A and B to not A and not B, and then we're also switching the places of it. So we're saying if not B, then not A. If you want to use more mathematical notations for this, you can say that A implies B, and it's identical to not B implies not A. But although these notations are not requirements for this level. Okay, so just remember that if you want to prove the implication, then we can try to prove the contrapositive of it. Okay, so what we're doing right now is we're proving the contrapositive. So let's try this example problem here. So once again, so why are we using this? If the only thing that we're doing to this um, implication is just changing the order of it, well, it's going to be useful if you think that proving the contrapositive is easier than proving the original implication. So right now, let's see this problem. Let n be an integer. Prove that if n squared minus 4n plus 5 is even, then n is odd. Well, at first sight, you can think that, even then odd kind of thing. That's doable. But if you think about the contrapositive, it's going to be much, much easier. So what I'm going to do here is, instead of proving the original proposition, I'm going to find the contrapositive and say if n is even, then n squared minus 4n plus 5 is odd. Now, this statement is a lot more simpler to deal with, so let's try to prove this statement. If n is even, then n squared minus 4n plus 5 is odd. So, what can I do about this statement? Well, n is even, so I'm going to suggest that assume that n can be represented as 2k. where k is an integer value, right? Even means that it's divisible by 2. So I'm going to say that n is represented as 2k. Now, let's try to rewrite n squared, then minus 4n plus 5 as 2k squared minus 4 times 2k plus 5, which is 4k minus 8k plus 5, which I can rewrite this into 4k squared minus 8k plus 4 plus 1. Then I can factor out 2 from the first three terms. 2k squared minus 4k plus 2 plus 1. This is a proof that the n squared minus 4n plus 5 is an odd value, because since k is an integer, then 2k squared minus 4k plus 2 is also an integer. Therefore, this expression is 2 times 2k squared minus 4k plus 2 is guaranteed to be even, and then plus 1 guarantees it that the final expression is odd. Therefore, 2 times 2k squared minus 4k plus 2 plus 1 is odd. Therefore, n squared minus 4n plus 5 is odd. Because we have proven that n squared minus 4n plus 5 is odd, it means that we have proven the contrapositive. So we can finally say then, therefore, the original proposition is true, proven by contrapositive. A good idea to approach these proof problems is always to um, directly, explicitly show that you're using the proof by contrapositive method, right? So that's what I did in this example problem here. Once again, the reminder that when to use contrapositive, when to use the proof by contrapositive is one, if the proposition is an implication, if A, then B structure. And also, if you think that the contrapositive would be easier to prove, then we use the contrapositive method. If you think that contrapositive is more complicated, then we don't need to use the contrapositive. We can just directly prove that implication. We just assume that the A is true, then we try to show that B is subsequently true as well.